Welcome, everybody,
Hello,
to
hello.
Hello. So tonight we're doing something a little different, you may have heard. We're going to be actually teaching a lesson starting every Tuesday night at 8 p.m. And we're going to kind of go through physics and math, mainly calculus, together, right, Jaden?
Right. We're going to try to make the calculus make sense with the physics. So we're kind of making this a combined course. Uh, Hopefully, we can explain it in a way that everyone will at least learn something, even if you have never done calculus before. So that's
Yeah,
our kind of our goal. And if you already have taken calculus, then hopefully you learn something anyways.
yeah. And along with that, physics and calculus go hand in hand, and physics is, anyways, we'll talk about it a little more, but it helps us understand the world, so
Yeah.
using math. But um, along with that, we will still every Thursday night be doing our tutoring sessions live. Can we call it ficulus? Yes, sure. We can call it that if you want. That's kind of hard to say, but uh, we can try. But along with that, we'll still be doing our tutoring every Thursday night at 8 o'clock. So you can learn here, and then if you have questions maybe from this, or if you have questions during, you can ask away in the chat. But if you
Yep.
have more questions, later, you can come to our tutoring sessions, or if you have other questions, go ahead and ask them then.
Awesome. All right, Kip. So, what is our first lesson going to be on tonight?
Dude, our first lesson tonight, as it says so beautifully here, is about reference frames, functions, and displacement. So we're going to kind of go through each of these tonight, and give a little bit of background to hopefully help us kind of get ready for the future course, right? This
Right.
course, like we said, is going to go through all these different physics and calculus principles, and so this is kind of tonight is the fundamentals, kind of the to get us thinking in the right mindset. Um,
Okay. And
so
if any of you have watched other episodes, I don't know if we're going to call them episodes or not. But anyways, have you been watching us at all? You might already know a little bit about reference frame. We have talked some about that, and hopefully tonight it will make more sense than the last time.
yeah. So, but before we get into that, Jaden, we got to start with, um, what is math, right? So, if we're going to be teaching a course on math and physics, we kind of got to figure out and explain what math is.
Right. So, what is math?
We got,
On
by
our
the way, we got a
side,
comment that says, "Is that actually what the universe looks like?"
uh, no, I don't think so.
I think so. Hopefully.
Okay. But anyways, so what is math? On our slide here, we have the language of numbers. So math, a little bit more deeply, right? This is the language of problems, of calculations, right? Math is its own language, and it helps us understand the numbers and these different problems that are all around us day to day. Do you have anything to add about that, Kip?
Uh, no, I think that's, I don't know, the language of numbers is how I like to think of it, right? Just like you have to take time to learn another language, if you're trying to learn French or Spanish or Japanese or whatever, it's gonna take time, and it's the way in which you communicate, right, to someone else and explain things. And so that's what math is. We get all these kind of crazy symbols that pop up and all these different things, and all that we have to remember is that is it's a way to communicate what these numbers are doing. Um,
Right.
so after we know what math is, we have to know what physics is.
Yeah. What is
And
physics?
so physics, Jaden, is it is the study of kind of how everything in the universe works. So it is kind of the building blocks, in my opinion, of all other sciences, right? And it explains and helps us understand what's happening around us. And we
Okay.
usually use math to describe these natural phenomena, right? So we can
Okay.
predict what's going to happen um, in the universe based on this language of math. So we take things that you normally, you see happening in every single day life, like if I drop a pen and it falls to the ground, well, there's actually math that you can use to predict
Right.
that, right? Um, or, why is the Earth spinning? You can use math to explain that. Or why, I don't know, how long is it going to take me to get somewhere, right? These are all physics principles, all
How do
ideas.
our phones work?
Yeah, everything.
Yeah.
And so I'm trying to think what I'm trying to say here, but it helps us better understand the universe, and we can kind of decide how complex of a model we want it to be, right? So if you have a car driving on the road, you can, to get kind of a basic idea, you can just say that car is driving on the road, but then you could add in, say, friction, and then you could add in air resistance, and then you
Uh,
could decide how precisely you want to model that air resistance, all these different kind of things. Um, and so depending on that, you can seriously branch into some, you can go down a rabbit hole pretty far, but the basic idea is that any natural phenomena you can kind of explain through math using physics.
okay. Yeah, I like that. I like being able to figure out what's going on around us, right?
Me too. And the cool part about it is too is it's kind of like stepping stones, right? We needed to know what math was in order to know what physics is. And then you kind
Yeah.
of, in my personal opinion, you start with physics and then all the other sciences follow after that, right? They build off of physics. So chemistry and biology, all these things build off of physics,
Oh,
which is all built off of math.
yeah. So we have this over like it's an umbrella is the math, and then you have all these other sciences that basically fall from the math and physics, chemistry, biology, all this stuff. It uses this umbrella, which is the language math.
Yeah, but I would argue that physics is
Physics,
like the second umbrella
physics is the
because
little metal things
yeah,
holding.
exactly, because everything else, does work kind of off of physics, right? Your biology, everything is based off of physics principles. Well, it's mainly based off of chemical principles, which are based off of physics. So I
What
could
would
be a little
you
biased. I'm not gonna lie.
what would you call the handle of the umbrella? I
I don't know.
don't know either.
Maybe physics is the handle. It holds everything up. Or maybe math is the handle and physics is the umbrella.
Okay, so without the handle, you wouldn't have an umbrella. Yeah, yeah, I like that. I like that.
Yeah, I think we're getting somewhere.
Okay. Anyways,
Okay. Anyways, moving on here. We're going to now move to reference frames. So
Ooh.
a reference frame is something that's we have comments that says mealtime with Mickey says hi, hello. And we have Jaden is the handle. Dude, you are the handle. You're not the person underneath. You are the handle.
Well, no, I would
You are
disagree with
math.
that. Good.
Okay, so along with that, all right, we got to move on to reference frames here. So what on
Yes.
earth is a reference frame? It is the point of a view that you observe something from. So, one of the classic examples out there is a car because it's one of the most notable moving reference frames that we've all participated in, right? Maybe not all of us, but most of us have been in a car at some point in time in our lives. And we've also stood on the side of the road and seen a car pass us. So
Right.
if we're in the car and we look out the window, it looks like everything, the trees and everything are moving behind us, right? But we know because we're in the car and we know that we're putting our foot on the gas pedal that we're the ones moving forward and the car or the trees are staying still. But in a reference frame, that's not necessarily true, right? You can think about it as you see those trees passing you, they appear to be moving backwards.
Right.
Um, we're getting some good comments over there. A car is a four-wheeled object that transports people using a engine. And we will try our best to publish a book. So maybe we'll make it a kid's book, a little cute story, kids book to get
That would
kids
be a good
interested.
idea.
Yeah.
Yeah.
And the handle snaps, and how everything else falls apart.
Well, yeah.
Yeah.
Brilliant.
Brilliant. Okay. So the trees are moving behind you, right? And that's perfectly okay, as far as physics is concerned, right? It doesn't really matter what your reference frame is as long as you know, calculate appropriately. Um, and so another way to think about this, in a car, yes, we normally assume that our car is moving forward, but if you have something in your car with you, you normally believe that that object is stationary, right? So if I have my phone in my car with me, I don't think of that phone as a moving object. I think of it as stationary. But that's because its reference frame is the same reference frame that I am in, which is the moving car. Um,
Right.
so it's the idea if you throw a ball up in a car, and we'll probably get into this later when we start talking about forces and things. Um, but if you throw something up in a car while you're moving, it's gonna stay in the same spot, right? Because of where it is in its reference frame. Um, and so now I would like to um, kind of talk about we're going to show some videos here, all right? And in the first one, well, in both of them, I want to point out what the reference frame is. So the reference frame is going to be these bars, all right? And so I want you guys to answer when I play this first video whether or not the blue ball or the yellow ball is what is moving. So let's see if I can get this video to play here. And there it goes. So I guys want you to know or comment which one is moving, the blue ball or the yellow ball. Okay, I can play it again.
Don't get this wrong, everybody.
Yeah, don't get this wrong. Which one's moving, the blue or the yellow ball? And while we're doing that, I'm going to pull out my phone because I took an Instagram poll earlier today to see what everyone else thought about which one was moving, and I'm going to let you know what they told me. So,
Okay.
88% of people said that the blue ball was moving. Okay? So,
8%.
yep, said that the blue ball was moving. And I'm waiting for those comments to come in. Oh, we got yellow
Yellow ball.
from, we got the yellow ball. Anyone else got a comment that they want to add? Blue. Okay, so we got a yellow and blue. Ooh, team blue, team yellow.
Okay.
Okay. So, Jaden, should we spoil it? Should we tell him?
Yeah.
So, the answer, oh, we got blue. We got another blue. So, we got 2 blues and 1 yellow. So, the answer is the blue ball is moving, right?
Okay.
And if we, oh, wait, no, I switched these around. But yes, Jaden, I switched them around. I didn't realize that. Okay, so we got the yellow ball and then we got blue, blue. So the answer is that the blue ball is still moving in this video. The reason behind it, like I said, that this, let's see here. Okay, so this is our reference frame, all right? Right here, these bars. And so what's actually happening is that the blue ball is moving, but so is our reference frame. So our reference frame is moving with the ball, which makes it look like the blue ball is stationary and the yellow ball is moving, all right? So we're gonna
Yeah.
go ahead and watch that one more time, and it's impossible for you guys to notice and know that it's actually the blue ball that is moving. And for that poll, actually, it was the opposite. And it was like 75%, 78% of people said that the yellow ball was moving. So I
Okay.
tricked all you guys. The blue ball is moving. And to show you guys it, I'm now going to show you guys a stationary frame and show you what is actually happening. So now, you guys obviously know and can tell that the blue ball is what's moving, right? And the reason
Right.
behind this is because this is a stationary reference frame. In the first video, it was it was a moving reference frame, so you can think of it as the reference frame of moving with your car.
Yeah.
And now we're looking at it as a stationary reference frame, saying, you know, you're on the side of the road.
Yeah.
Cool, Jaden.
That's really, it's like you gotta put yourself in these situations to actually like figure out the blue ball is moving in that first video. All right.
Right, because
It otherwise it looks like the yellow ball is always moving, right? It's going across the screen this way. It has to be moving, Kip. But when you say, right, our reference frame are these lines, our blue ball is moving with the reference frame. So that makes it look like it's like you're in your own car flipping up a coin or whatever, right?
right.
And second, it's clear that the blue ball is moving from the outside perspective.
Right. So I got asked, can we show it again? I just showed it again, the first one, but I'm going to show it again just to quickly go over it. So in this video, the yellow ball is stationary, but the camera and the lines behind the camera are moving at the same speed as the blue ball. And so it's a moving reference frame because it's moving with the blue ball. So it makes it seem like the yellow ball is moving when it's actually not. It is stationary. But as far as physics is
Right.
concerned, right, the blue ball is stationary. And that's kind of the whole point of this, is that even though the blue ball is moving, from a physics perspective, we can say that the blue ball is stationary and it is the yellow ball that is moving. Um, and that's, like us on the planet Earth, right? We sit there and we feel like we are stationary right now, right? But we know that the Earth is rotating and it's revolving around the sun, and then our whole solar system is moving through the galaxy. But we claim that we're sitting stationary right now, right, Jaden? Me and you are not moving.
Dude, I'm not moving.
And that's because we are
Yeah,
on the Earth's reference frame right now, right? But if gravity didn't work and all these other factors didn't work, and if you're just floating right above the Earth right now, Jaden, right, you would just watch the Earth float by you. So
right.
it's like
That's
someone in the
crazy.
International Space Station, if they could look at you right now, they would watch you slowly rotating away.
Bye.
Bye.
Yeah, reference frames are really cool, Kip. I like getting in this mindset of thinking of all the possibilities of different reference frames that are out there. It's really interesting. And thank
Yeah.
you for those videos. They were excellent.
I'm learning my animation skills as we go here. So,
Heck yeah.
okay. Oh, look, now they're
All right.
loading on there. That's whack. Okay. Um, so, all right, Jaden, do you want to talk about functions now that we've learned about reference frames?
Yes. So functions at its most basic, a function relates your inputs to your outputs. And your inputs cannot have more than one different output, meaning it can't, like if you put in one, it can't go to 2 and 3 at the same time. Okay? So that's not a function. That could be a relation, not a function. Okay? Here's a real simple example with our little bubbles and our lines with numbers and letters. Okay.
So, yeah, Jaden, I've got it
Uh,
set up with animations over here so we can like show that, as we get from, let's see here, 1 goes to B, right? And then we go to
right.
2, or I guess I got 3 here. 3 also goes to B, maybe? I'm not sure here. But yeah,
Yeah,
what is
that's
happening?
fine. For
Ah, I went too far. Okay.
are the arrows messed up?
Yeah, the arrows got messed up somehow. Whoops. Um,
Oh,
that's okay though, because they can all go to B. That's the important part, right?
still works. Yeah, and we'll learn about this in our handy dandy vending machine example. Okay. So anyways, you have these inputs which are our numbers, and they are mapping to, or they are receiving these outputs which are letters, and none of our numbers have more than one line coming out of it, so that makes it a function. Okay. uh, Now for like a real world example, if you guys think with me about vending machines real quick, and we have this wonderful example, this red vending machine here. It appears to be cans of soda of some sort. So a vending machine, right? You put in your money, you type in like A3, right? And you expect to get, what is that? That looks like a, let's say A is the top row, B is the second, or yeah, and then bottom row, and then numbers we can say 1 through however many cans of soda. But let's say I
Let's
said
see here. I think
A3.
there's
That looks,
7 cans of soda.
yeah. So that looks like uh, a coffee bean of some sort. I don't know. We'll say coffee. Soda, coffee. I don't know. But A3, I push that in. I expect to get this coffee soda. Okay. Now let's say I put in C3. That looks like maybe Coca-Cola. Right?
Yeah.
Okay. But if you notice, there are many different sodas that have more than one, right? Let's take, for example, the Coca-Cola. There would be three inputs that receive that Coca-Cola. Okay, so I could type in C1, C2, and C3, and I'll get that Coca-Cola. And that is perfectly fine, right? Our vending machine is still functioning properly. Okay, but now let's think, what if I push in A3 and then I get this coffee can and then I also get the Coca-Cola from the bottom? That would not be functioning, right? If,
Well, I think I'd be happy,
yeah, most people would probably be happy, right? Like,
except for the
let's
person
make
that
this
owns the vending machine.
yeah. Anyone putting in the inputs would be happy. The company that owns a vending machine would not be happy. But anyways, that would be considered not functioning properly, right? We have one input giving us two outputs. That cannot happen with functions. Okay. Anything else you want to add with that vending machine tip?
Uh, no, dude, I think you're killing it here with the inputs and outputs things. Anyways,
Are
it's
there
making sense to me. So, if you guys have
any
questions,
questions?
please don't be afraid to ask questions. Um, but yeah, just you just to clarify for my sake, right? You put something in and you're expected to get something out, right? And you
Right,
can have the same output multiple times, but from one input you can't get multiple outputs, right?
right, right.
Okay. So,
Yes.
yeah, and so you
Okay.
think of it, like it's kind of like this, a function's almost like a machine, right? You put something in and you get something in return. Um,
Right.
and so, I like to think about it. Apparently, I'm the only one the more I talk to people about it. But in like elementary school, so we have, can two inputs equal one output though? And the answer is yes.
Yeah.
So like
Right.
we
I
can,
put in C1 and C3. I expect to get the same output, which is that red Coca-Cola looking can.
right. So there's
Right.
multiple spots, yeah, that can have the same output. Um, but yeah, I like to think of it as like the in and out machines that apparently I was the only one in elementary school that did. But you can picture like a little machine and you put a number in or you put something in and it goes bloop and spits something out. Um,
You have to figure out what the function is that spits that output out.
right.
Yeah, I like
Yeah. So,
that.
all right. So let's
Okay,
continue with functions here, Jaden. Do you want to keep us going with the
so
functions?
yeah, functions continued, right? Uh, we have vertical line test with graphs. We will get into this a lot more on our next slide, but actually it is if you
Jaden, I'm losing you. Jaden?
on a
You're Jaden, you're breaking up. Hello? Jaden!
hello,
Jaden, you're back. Oh, you're back. Where'd you go, dude? Did you go to Mars?
I'm back.
Yeah, you're back.
As I was on the rover, I was taking the videos. Okay,
Nice.
but I'm back now.
You're back.
So
Dude, that was
anyway,
some fast traveling.
functions continued, right? Uh, I was saying vertical line test with graphs. We'll talk about this a lot more on the next slide, but essentially, if you can hold your pencil vertically or pen, I have a pen in my hand, and if you move across the graph like this, I'm doing across my screen, and if you only touch your function or your graphed line or equation, only one at every spot, then it is considered a function. But let's say you have like a weird curve going this way, like a C almost, right? I would pass that twice. That is not a function, okay? But a line function, it's only passing at one point at any given time. Okay, so that's the vertical line test. We'll show you a little bit better with an actual graph. Uh, now we have independent and dependent variables. Okay, so an independent variable doesn't depend on any other variable, right? Whereas the dependent variable depends on the independent variable. Okay. Generally, you'll see this as x being the independent and y being the dependent. So, for example, if we go to a grocery store and if you go to the produce section and you really like apples, right? Our independent variable is going to be how many pounds of apples we buy, where our dependent variable will be the cost of those pounds, right? Because I choose how many pounds I buy, and the dependent variable depends on that independent, which is the cost. I know there's a lot of depends, independent, all that stuff,
Yeah.
but hopefully you're following. So yeah, did that make sense to you, Kip?
Uh, yeah, I
Did we
think it made sense to me, but I've dealt with this stuff a lot. Um, and so, I mean, I think it makes sense, but I'll throw in my 2 cents too, if that's all right, if it won't offend you,
yeah,
make you cry at night. So I like to
sometimes
think that,
I just go fast, and I realized that after I spewed, and then I said, "Wait a minute."
so, I mean, I think that you gave a great example of what an independent variable is versus dependent, but I think I mean, it's all in the name, right? Like an
Yeah,
independent variable is something that doesn't rely on anything else. And maybe you said that, and maybe I spaced out. And then the dependent variable relies on the independent variable, right? So
yeah,
I like to think of the independent variable as it's independent, right? It's free. It can do whatever it wants. And then the
yeah,
dependent variables are kind of like its followers, right? It follows after the independent variable. The independent variable is like, I'm so cool. I can do whatever I want. And then the dependent variables are like, look at that guy. I'm gonna do what he's doing.
yeah. But I'm
So,
gonna, yeah, I'm gonna
but
just be kind of like output.
yeah, exactly.
Yeah, yes, I like.
Okay, yeah.
Any
Um,
questions? Just type them in the chat, please, and we
yeah,
can
please,
try and.
guys, we love questions. It makes our life easier. If you're confused, please ask away. Okay,
Yes.
so let's move on to graphing, and I'm gonna go ahead and pull up our Jamboard, Jaden, so we can switch to that
Yeah.
and get there. Do do do. Oh gosh, I gotta hide that. There we go. Okay.
Okay. So
So Jaden, what is graphing?
graphing is a way for us to visually see what our function is doing, right? This is an easy way that we can relate the inputs to the outputs. We can clearly see if it is a function by the vertical line test. Uh, we we can see how the dependent and independent are changing throughout our graph. So yeah, basically it's a way to visually see what our function is doing. Okay, should we do a couple easy functions and just draw like linear equations or something up there and just look at them and then we can
Dude,
draw.
I don't. I mean, I mean, we can do it that way, or I'm honestly happy to just like draw dots all over the graph, and we don't even need to show an actual
Yeah,
function. I mean, that's kind of
well, you can have a scatter plot, and
yeah,
it could be a function. That would be kind of like a vending machine, anyways.
yeah. So, I
Okay.
mean, why don't we start, Jaden, by talking more specifically about this vertical line test? And so we're taking, this idea
Okay.
of one input to multiple outputs, and now we're going to put it on a graph, right? And showing how that's bad, right?
Right. Okay. So if you can see on our graph here, I've put several points, right? This could be considered a scatter plot. Now, if you would, everyone at home, grab some sort of straight utensil. Could be a fork, a spoon, a pencil, a pen, a straw. I guess you could do a ruler, a finger, maybe. I don't know. But
Well, if you
anyways, do
got
this with me.
weird bent fingers, dude, maybe you broke your fingers.
Then don't use those.
Ooh,
You
an
know,
umbrella? Use the rod of an umbrella, the handle.
you could. It might not be very efficient, but go for it. So, anyways, at home, you're seeing our graph here with a whole bunch of points on it, and go across with your vertical line test to see if your pen, pencil, whatever you're using touches two dots at any given point at the same time. And if it does, it is not a function. If it doesn't, it would be considered a function. Kip, are you doing this?
Oh, sorry. Here, let me go. I'm gonna scan back now. Jaden, I ran into an issue.
Where at?
Dude, right here.
It's like, uh, yes. So, right there, we already know this is not a function because our input, which is our x value, right? It would be this point right here, gives us two y values, boop and boop. No good, not a function.
Yeah.
Okay. All
So,
right. Now, yeah.
yeah. So, Jaden, maybe we need to talk a little bit about the representation on a graph of what this x is and kind of what this y is, right? Because you said that we have this x value and we have two y values at that point. So, I think we've kind of briefly talked about how it's x is normally the independent variable and y is normally the dependent variable. But I don't know, maybe people are able to understand. But I think that this is a really crucial thing to really help people understand, is this idea of what x actually is and what y actually is, and the
Uh,
plotting of these points. And maybe it would be best, I don't know, you recommended we actually draw like a line and write it out. But I'm just trying to think, it's like this idea of, okay, I don't know, what is x and what is y on a graph, and how does that relate to an independent variable versus the dependent variable?
okay. So I just drew on our graphing page a coordinate pair x comma y, right? X is generally our input, right?
Mm-hmm.
Input, our y is the output. Okay.
Okay.
So oftentimes our like when you're first learning this, you're dealing with linear equations, which is an equation of a line, and it is in the form y equals mx plus b, where our input deals with the x and our output happens when you just do a little bit of arithmetic with the mx plus b. Okay. Uh,
Okay.
with scatter plots, obviously that's not a line, so we're not using this equation. But we can still write ordered pairs for these points that I've drawn on the graph, right? So in this situation, we have positive going up and to the right. So those we know are going to be positive, and then negative is down and left. Okay, so we know our x value will be negative where we ran into a problem, and we just got to count the little squares, assuming we are on a scale of ones, right? So that would be -1, -2, -3, -4, where we run into our issue. So we know our x is going to be -4. Let's put that as an ordered pair. And one of our points for the y value was up 1, 2, and we know up is positive, so that is going to be a +2. And our other point, we still have the same x value, right? The same input, and our output was down from our middle axes, right? And that would be a -1. Okay, so this, just kind of writing it out, maybe that helps a little bit more, visualizing our x is our input, our y is the output. This is where we run into the problem with these two different y values.
Awesome. Cool.
Right.
So yeah, I think that that helps clear things up. So Jaden, just out of curiosity, if I erase
Yeah,
this point at say, you know, this -4, -1, now is that a
yeah.
function? What do you think?
Let's do the vertical line test again, right? And we can erase this because that looks like a jumbled mess too. Uh,
Oh yeah.
these points, we can use a vertical line test again.
Scanning, scanning, scanning. Dude, we're good.
And this situation, this would be a function, right? We don't
Right.
have any input giving us two different outputs, two or more, right? You
But we
could
do
have a
have
bunch.
two, we have two different inputs, right, that gave us the same output, right? Because
Yep.
there's several places that have the same y value.
Yeah, like these, right? And
Right.
these two. Yeah, and that is okay, right? Think about our vending machine. If these happen to be soda, maybe the y equals 2 could have been like a Coke, right? Coke is a pretty popular soda, and maybe the one where there's two different ones that could be like a root beer. Root beer is pretty popular. I don't know.
Yeah.
Okay, so
Awesome.
that is really good and okay for functions.
So one last thing I want to add, another way to see a function written is lots of times you'll have f, normally it's an f, but you can use anything, right? So you could say like
Right.
f of x, which means the function is, you know, is dependent on x. That's what that means when you see something like f of x equals something. So that means the function is a function of x. Or you could
Right.
say d, right? And so when we move on to our next slide here, that's going to be really important because we're going to go back to this kind of ball example, show that how as the ball moves with time, how
Right.
where it's at is going to be a function of time. So we're going to go ahead now and switch back over to here and go ahead and start talking about displacement. Okay. So,
Okay.
oops, I put is in there twice. It is. It
It
is.
is.
So it
Yes.
is the change in position of an object. All right. So
Okay.
I forgot to double check my second statement here. But displacement is where the object currently is. All right. So Jaden, let's say that I walk, you know, a mile away from my house. All right. My
Uh-huh.
displacement at that moment will be 1 mile, right? But then
Right.
let's say I walk back to me, right?
Right.
Or back to my house. So I
Uh,
walked a mile away and then I walked a mile back. What is my displacement when I'm standing right here at my house?
your total displacement,
Yeah, what is my displacement?
that would be 0, right?
Right, it would be 0. Even though I walked a total of 2 miles, my
Right.
displacement at the time I have gotten back here would actually be 0. Um, so that's something. So displacement is a little different than say the total distance you traveled, right? The total distance you
Right.
traveled would be the total distance I would have traveled would have been 2 miles. But displacement is what we use in physics a lot instead of
Yeah.
distance, right? So we try to figure out at a certain point of time where this object is at. And this is where reference frames start to come in really important, right? Because
Uh,
you're looking at that displacement from a certain point. Um, and so we'll kind of get into that a little bit more. But the kind of how we're tying this all together is, so we learned about what math is, what physics is, and we learned about reference frames, and then we learned about functions. And so now we're kind of start looking at how displacement is a function of time, where time is going to be our independent variable, right?
yep.
And displacement is going to be dependent on that. So depending on where you are in time, your displacement is going to change. Um, so we're going to
Right.
go ahead here and I'm going to show you guys some video clips and we'll see if they work this time the right way. So again, this is a video. This is the same videos as before. So in this first video is going to be the blue ball moving, and the second with a stationary reference frame, and the second video is going to be a moving reference frame. And we're going to plot out on both of them the blue ball's displacement in the first one, and then the second one is going to be the yellow ball's displacement, okay? And so we're going to
Right.
put them on a graph, and so you can see how this is a function. And so we can see here, right, that we've got this function, or our y value is going to be this dt, right, which is going to, that means displacement as a function of time, and then our x-axis is going to be the time. So that's how this
Okay.
is going to work. And so we're going to go ahead and watch this video now. And
Nice.
it's not working, so I'm going to have to switch it, and that's perfectly all right. Here we go. Well, let's try this again, shall we? There it goes. Okay, so we watch as that ball moves forward. I'm going to show it to you guys again, if I can find it. So that blue ball moves forward, and as it's moving forward, we can watch that graph, right? The graph is going up, the ball is going up, and each one of those horizontal lines that go up is the
Yeah.
displacement, and each one of the vertical lines is further in time, right? So as the ball moves, its displacement is plotted going up. Um, so now I'm going to go and show you it with the moving reference frame. And so we can see here that the yellow ball, right, because it's moving towards the blue ball,
Uh-huh.
the displacement is going down. It's starting and then it moves its way back down. In physics, in order to signify direction, we don't have the luxury of using, we can't describe direction in math the way we would in the real world, right? So the way we
Yeah.
do it is by negative and positives. So if you see a line that's going down, that signifies negative, right? And if you see a line going up, that signifies positive. Um, Anything you want to add to that, Jaden?
Um, yeah. So kind of like what you said, where in math we use negatives, right? In the real world, you wouldn't say behind you is negative. You wouldn't, right? You might give like a specific direction, like head northeast, right? But you wouldn't be like go negative 4 miles, and people would know what you mean. That just doesn't happen. They might
Right.
understand you if you're like go 4 miles east, then they could figure out what you're talking about. But yeah, in math and physics, we just use negatives, and that just makes it really easy.
Yeah. And along with that, the other thing, remember we talked about reference frames and displacement. In the second video that I'll show again here, we noticed that it starts further up on the graph, the yellow ball, and works its way down, right? That's because we decided that the 0.0 displacement was from the blue
Yeah.
ball. Um,
Yeah.
and so as it had to start further away, right? It started 5 lines up and then worked its way down as it got closer and closer to the blue ball. So that's how we can visually represent what happened to this ball over time on a graph, is that each one of those lines represents that it's getting closer and closer to that ball. And at the very end, right, we have this whole graph that's spread out. And now we can go back and look at that graph without having to watch it actually play out and know at a specific time where this ball was in both examples, right? We can figure out
Right.
where the ball was in both examples. Well,
Yeah,
Jaden,
it's
did
awesome.
we? I, I think we're ready to move on to our questions, unless there's something that I'm missing.
No, I like what you said that last part, right? If we have this graph of what an object has done, whether it's displacement versus time, at any given point in time, we would be able to tell you where that is. And that's really important in, for example, if you're trying to figure out where your satellite is, right? We should be
Right,
able to know where that is from the function that is written for that.
right. And we can, and not only, in this video, it plotted it out as it went, right? But if we
Uh-huh.
knew certain parameters that we're going to talk about next time, we could actually plot this
Uh,
out before it happened. So we could predict the future, dude. We could be psychic. Ooh! We could know what's
Dude,
going to
why
happen before it actually happens. What?
is why is it math and physics called magic and
Dude. Oh,
psychic?
wait. Guess what it is, though, dude? What we've been talking about is definitely mathematical. So there you go. It's math
Math.
and magical at the same time. Okay, we've got why is the yellow ball moving now? So that's a great question. Um, so it's not necessarily that the yellow ball is moving, right? But what we've chosen to do, and like I was explaining, in the physics world, we've chosen that the blue ball is now the reference frame, right? And so
Right.
from there, we can say that the yellow ball is what's moving, even though it's stationary. And this is where the math and physics work out, because in both examples, we can notice that the blue ball and the yellow ball, their displacement is the same, right? So the total displacement is the same. And so because we chose
Total.
the
It's
what?
the total distance, right?
Right, thanks. Yeah. Um, and so we chose it depends on what you're trying to do in physics. And thank you for clarifying this. Um, for example, if we're trying to calculate, how fast a car is moving on the Earth, it makes a lot more sense to choose the Earth as our reference frame than, say, a frame out in space, right? Because then we have to add into consideration rotational speed. We have to take into consideration our revolving speed around the sun. and all these other factors. And so when we're trying to do things more simply, we choose the easiest reference frame and set that kind of as the 0 point, right? And everything else is moving around that. And so that was, in both situations, the blue ball is still what's moving, but we've decided to say the blue ball is what's stationary and the yellow ball's what's moving. So it's like if you're driving on the freeway, right, and you're passing another car coming the other direction, that car is moving at the same speed as you. You can either say you're moving at 65 miles an hour, or you can say that that car is coming at you at 130 miles an hour. Both are completely and totally accurate statements as far as physics is concerned. So.
Right. Cool.
Cool. And it doesn't change the
Awesome.
fact that both the cars are moving, but you could claim that you are stationary. Okay. Any other questions? Look, we got our little coffee. There we go. Questions with or soup.
Coffee.
Whatever it is, dude. It's soup. And yeah, we're gonna start eating soup at the end of every one of our lectures.
Yes. That would actually be just wonderful.
Alrighty, so thank you guys for watching. We really appreciate it. Next week, I believe what we're going to be starting to talk about is what is a derivative. And Jaden's going to super cool on that for us. He's going to explain it lovely.
Are we going to skip limits?
If we want to, yeah. Let's go limits, derivatives, and I think we're going to go into probably what is acceleration and what is velocity, since those are the derivatives of displacement.
Hey.
So, and
man.
so if you guys are interested in that, please like and subscribe and turn on the little bell in the corner so that you'll get notified when we go live again. Again, every Thursday we do tutoring, so if you need extra help, you can hop on then and ask away. Yeah.
Okay.
One more thing that I was going to say, Jaden, and I'm trying to remember it as I'm speaking out loud here.
Yeah.
What was it, Jaden? I've completely spaced now.
I can't read your mind. Darn it.
Darn it. Thank you guys for all your comments. It makes our lives easier if you ask questions, because me and Jaden, we're just talking to each other. We have no idea what's happening to you guys. If you guys are confused or not, we have no idea. So if you
know most of this stuff. All right. So more questions you ask will be better for yourself.
I remember now what I was going to say.
What is it?
So my big belief as far as learning anything is applying it into your everyday life, right? So my homework, even though I said on my Facebook post there was no homework for this class, that's not entirely true, but it's going to be way different homework than what you're used to. So in this coming week, I want you guys to think about different reference frames that you find yourself in, and how there could be different reference frames. And then also think of just daily tasks that you do or things that you do throughout the week that you could see as a function, right? Something that's an input-output relationship. And just kind of be thinking about those things, and that will help you guys prepare yourselves for next week.
Use the vending machine example and the grocery store example to find other ideas that are similar to that.
Yeah, I mean, and the thing is that most of you guys are doing function type stuff on a daily basis, right? You go to the store and you see one of those signs that says it's like, Or you go to the grocery store and it says it's $3 for something, and you're like, oh, well, if I buy three of them, that's going to be $9, right? That is a function, and you just don't even realize that you're doing it.
Yep.
So,
Okay.
alrighty.